Let's do something a little bit different. Now we're going to deal with stuff where it has at least or at most in the question. So a committee of 5 people is to be formed from a group of 4 men and 7 women. How many possible committees can be formed if at least 3 women are on the committee? So here, order doesn't matter, definitely a combination question. The at least is a key word though, and it's even underlined and italicized for you. We have a couple different situations. So we have a total of 5 committee people. We could have 3 of them being women, we could have 4 being women, or we could have 5 being women. Those are all our possibilities. Now, if we have 3 women, that means we're going to choose of the 7, we're going to choose 3. For 4 women, it's going to be 7 choose 4, and for 5 women, it's going to be 7 choose 5. Now we have to deal with the men as well. So there is 4 men in total. So if 3 of the committee members are women, that must mean 2 are men, meaning it's going to be 4 choose 2. And here, again, for 4 women, that means there's only 1 man on the committee, so then it's going to be 4 choose 1. And if they're all women, it's going to be 4 choose 0, which is just equal to 1. Now, again, we want all the different combinations between the women and men, so it's going to be multiplication for all of these. Now, all of these are actually independent of each other. So we're going to add these all up. We're going to add all the possibilities if there's 3 women, plus all the possibilities if there's 4 women, and all the possibilities if there's 5. And we'll add those separately. So I use the calculator for this one. So when I do this multiplication, I got 210. And then we got plus 140 plus 21. And when we total that all together, we get 371. And there we go. So there's all our different possible committee amounts. So our next example, very similar. A bag contains 7 distinct black balls and 6 distinct red balls. And how many different ways can you draw groups of 5 balls if at most 2 must be red? Now, first of all, we don't care what order they're actually drawn. So we don't care if one's drawn before the other. And also, these are distinct. So we're going to be able to see the difference between the different balls. So we've got some different, the most though, so we have some different possibilities here. We could have 0 red balls. We could have 1 red, or we could have 2 red. So there's a group, what do we have? 6 red balls to start. So we're going to be choosing from that 6. So if there is 0 red ones drawn, it's going to be just 6 choose 0. If there's 1 drawn, it's 6 choose 1. And if 2 are drawn, it's going to be 6 choose 2. So that deals with all of the red balls. Now we're going to deal with the black. So here we're drawing, how many are we drawing? 5 in total. So if we drew 0 red, then we must have drawn 5 black in total. So there are 7 black to start. So it's going to be 7 choose 5, because again, we're drawing a total of 5. And then here, if 1 is red, that must be 4 is black. So 7 choose 4. And here, if we've drawn 2 red, we must have drawn 3 black then. So 7 choose 3. Again, we want the combination of all of these red and black for this situation. Same for here. So it's all going to be multiplication. Now, these are separate probabilities though, so we're going to add the totals together. Now, again, I used a calculator to figure out what each of these are. There's quite a few here. So this one was a 525 plus 210 plus 21. And when you total those all together, you get 756 possibilities.